On the left, paper is folded into an origami crane. On the right, the same paper catches a flame and blackens into ash. Both pieces of paper underwent a visible shift, but while the crane is still unmistakably paper, the ash has become something else entirely. One is a shift in form, the other is a total break in identity. The origami crane represents a physical change. We have altered the shape and size of the object, but the internal structure of the material remains untouched. No new substance appeared during the folding. Activity 1 shows this logic applied to a wooden stick. Breaking the wood into smaller pieces changes its appearance, but each fragment retains the properties of the original branch. These changes affect the how it looks, but they rarely change the what it is. Burning that paper on the right side of the screen is different. The heat destroys the original material, reacting with oxygen to create ash and smoke. This is a chemical change. You cannot unfold the ash to find the paper again. The original matter is gone. Think of a physical change as a change of outfit. A chemical change is the point of no return, the birth of entirely new matter. To understand why, we have to look at the atoms. The starting ingredients, or reactants, disassemble their connections and shuffle into new geometric arrangements to create the products. Because this atomic shuffling is invisible to the naked eye, we have to rely on macroscopic evidence to prove a transformation has occurred. In Activity 4, the sudden appearance of gas bubbles signals that a reaction is underway. When baking soda and vinegar meet, they don't just sit there, they actively produce a new gas that escapes the liquid. Activity 3 illustrates a different sign, the formation of a precipitate. By blowing exhaled air into clear lime water, a solid white substance suddenly forms in the liquid, turning it milky. A solid has appeared where there was only liquid and gas. Even a shift in color can signal a new substance. When iron reacts with oxygen and moisture, it yields rust, a brittle orange material with none of the strength of the original metal. These specific markers, bubbles, spontaneous solids, and permanent color shifts, provide the visual proof that the atoms have successfully rearranged themselves. These transformations involve more than just a movement of matter. They also move energy. Reactions that release heat are exothermic, while those that pull heat in from the surroundings are endothermic. When we look closely, we can see that combustion is by far the most violent and dramatic version of an exothermic energy release. In Activity 5, we see a magnesium ribbon burning. The energy release is so intense, it creates a blinding white light and a new powdery ash. The reaction is fast, hot, and permanent. However, this energy isn't released at random. It requires specific environmental triggers to begin. This fire triangle defines the 3 ingredients for combustion: fuel, oxygen, and heat. Removing one side stops the chemical change, but providing the missing piece, like concentrating sunlight with a magnifying glass, triggers the ignition point, and it burns. Combustion demonstrates that chemical changes are energy-driven events that rely on strict environmental conditions. While these signs are powerful, we have to be careful not to mistake a simple change in state for a chemical transformation. Take dissolving sugar in water. The crystals seem to disappear, but the sweet properties remain in the liquid. If you boil the water away, the solid sugar crystals are recovered. It was only ever a physical mixture. But some objects exhibit both types of change at once. Consider the burning candle. As the flame burns, solid wax melts into a liquid puddle. This physical change reverses when cooled. Simultaneously, vaporized wax reacts with oxygen to produce light, heat, and carbon dioxide, a chemical change. Under a glass jar, oxygen is cut off, and the flame dies. This same exothermic logic applies to the digestion of food. Our bodies perform a slow, controlled form of combustion, using oxygen to break down nutrients and release energy stored in atomic bonds. It's a biological version of the fire triangle. Whether it is a stomach digesting a meal or a candle burning in a jar, the rule is the same. If the invisible identity of the substance has been rewritten, a chemical change has occurred. Look for these transformations in your own kitchen or the outdoors. From the rust on a bicycle chain to the sizzling of an egg, you are surrounded by the constant birth of new matter.